Alrighty, so today we're going to be having a look at the null factor law and solving quadratic equations. And this is why factorizing is just such a powerful tool. What does null factor law say? Well, if I have a times b, well, let's write that as ab is equal to 0, then what can we say about a and b if I know that a times b equals 0? Well, let's think about cases in which something equals 0. So if I've got 6 times 0, that would be equal to 0. And if I had 0 times 15, that would be equal to 0. Or 0 times 0 is equal to 0. Those are the three options I've really got. Either b is equal to 0, a is equal to 0, a is equal to 0, or they're both equal to 0. And that's exactly what the null factor law says, is that if this is true, then it is true that either a is equal to b, 0, b is equal to 0, or a is equal to b is equal to 0. So that's what the null factor law says, and it's a super powerful rule. Why? Let's have a look at this first one down here. Imagine we wanted to solve for x. We've got x minus 3 times x plus 2 is equal to 0. Well, either a needs to be equal to 0 or b needs to be equal to 0. Meaning we have two solutions. If this is equal to 0, then we'd get x minus 3 is equal to 0. Therefore, x would be equal to 3. Let's call that x1. Because instead, what if x plus 2 was equal to 0? Well, then x would be equal to minus 2. So null factor law allows us to quickly solve any sort of quadratic equation once factorized. Meaning, what if it's not factorized? Well, if it's not factorized, then hey, we better factorize it first. So for this one, it's a direct factorization. These both have a common factor of x, so let's pull that out the front. We're left with x minus 3 inside the brackets. And we've got the two options. Either x is equal to 0, this is all equal to 0, by the way. This only works if it's equal to 0. Null factor law needs that equals to 0. So either x is equal to 0, that's our first solution, or our second solution is that x minus 3 is equal to 0. So therefore x2 would be equal to 3. So those are our two solutions in this case. Let's have a look at one more. This one we actually do have to do full decomposition. So let's quickly go through and do it. T chart up, times to AC. 1 times 1 is 1, so we're looking for numbers that are multiplying to 1. Add to B adds to negative 2. So it's either 1 times 1 or it's negative 1 times negative 1. And hopefully everyone can see that it's going to be negative 1 and negative 1. So decomposition, minus x minus 1x minus 1x plus 1 equals 0. Factorize each pair. X squared minus 1x, well, that's just x minus 1. Now in this case, if I just factorize out the 1, then I'm going to be left with minus x plus 1, which is a problem because that means that these two brackets don't match. So in this case, I'm actually going to factorize out the negative as well. So I'm going to bring out the negative out the front, negative in there. Right. So if I pull out a negative 1 from here, I'm left with x in the first term, and negative 1 times negative 1 equals 1, equals 0. And in this case, I could now finish up my direct factorization. Pull this out the front, x minus 1, and I'm left over with x minus 1. Except, that's curious. What's x minus 1 times x minus 1? It's x minus 1 squared. So this is indeed only going to have one solution, and using null factor law, we could say that that one solution is going to be x minus 1 equals 0, so x is equal to 1. Alrighty, so that is a brief look at 3 different quadratics and how to use the null factor law to actually solve them. Alrighty, I'll see you on the next one. Goodbye.